Welcome to the Explainer. Today, we are diving straight into how you can absolutely master the ultimate Kubernetes architecture interview using a really powerful cognitive trick. Because look, if you're preparing for a senior systems role, you already know that just reciting the theory, that isn't going to cut it. You have to actually prove you can navigate the gritty operational realities at scale. So we're going to build a mental map together that will help you do exactly that. Okay, let's set the scene. You're in the hot seat, and the interviewer drops this classic, terrifying question. How does Kubernetes work end to end? It is a massive, loaded question because it's checking your true understanding of literally the whole shebang. The control plane, the internal workflow, etcd, the scheduler, the controllers, the kubelet, and those endless reconciliation loops. And honestly, they don't want a textbook definition. What they're really looking for is that rare intersection of high-level architectural vision and deep-seated, battle-tested operational expertise. So, here is our agenda to tackle this. 1. Master the architecture interview. 2. The declarative relay race. 3. C.H.A.M.P.I.O.N, the control plane. 4. I.O.N, the execution loop. And 5. Operational realities and wrap-up. Let's kick things off with Section 1, Master the Architecture Interview.
Listen, you really need to use this 5-layered response progression. Think of it as your absolute blueprint. You don't want to just start rambling about pods and nodes right out of the gate. Instead, you begin with a snappy 30-second conceptual intro. That's your hook. Then you move into a 1 to 2 minute high-level executive summary. Step 3 is where you spend a couple of minutes on the detailed technical mechanics. Now, Step 4, that is your golden ticket. That's the operational insights layer where you share what actually breaks at scale. And finally, Step 5 is a quick 1-minute wrap-up where you standardize your answer into a proactive framework. This specific cadence effortlessly drives a logical flow and feels incredibly polished to the person listening. Moving right along to Section 2, the declarative relay race. When they ask you that big end-to-end question, you want to look at them and say exactly this. I like to think of a Kubernetes deployment not as a single command, but as a declarative relay race. It's such a brilliant way to illustrate that Kubernetes is handling all the grueling heavy lifting of distributed systems using decoupled, event-driven handoffs. It sets the stage perfectly. It proves right away that you understand Kubernetes isn't just about executing commands. It's providing a declarative abstraction to hide all that massive complexity. Now, to explain how that race is actually won end-to-end, you introduce the C.H.A.M.P.I.O.N framework. This is your cognitive anchor. It takes a really complex, multi-stage architecture and turns it into a totally natural train of thought. C.H.A.M.P.I.O.N stands for client admission, hardened ledger, alignment, matchmaking, provisioning, interfaces, observation, and nonstop reconciliation. Let's actually break this down step by step so you can totally ace layers 2, 3, and 4 of your interview response. Which brings us to Section 3, C.H.A.M.P., representing the control plane.
The journey starts with C for client admission. Basically, your client submits a request to the API server, which is acting as the ultimate gatekeeper, running authentication, authorization, and admission controllers. But here is the operational reality you've got to drop. Slow, mutating webhooks, like sidecar injectors, can actually cause kubectl timeouts and completely block your CI/CD pipelines. Once admitted, we hit H for hardened ledger. The API server persists that desired state into etcd, and look, if it's in this ledger, the cluster is committed to it. Operationally, you want to warn your interviewer that etcd is incredibly sensitive to disk I/O. In massive clusters, high churn can trigger leader election failures if that disk isn't optimized for low latency. Next up, A is for alignment. The controller manager is just constantly watching the state. It sees a new deployment and aligns that high-level intent with low-level execution units, spitting out replica sets and pods. But operationally speaking, if your controller manager is resource-starved, you are going to see a lag where pods just aren't being created, even though the deployment reported as successful. Then we've got M for matchmaking. The scheduler steps in to find the absolute perfect node venue for those unbound pods, based on resources and constraints. For the interview, definitely point out that at scale, we're talking over 5,000 nodes, scheduling latency really spikes, and improper taints or tolerations can easily create hot nodes and localized outages. Finally, rounding out the control plane handoff, P is for provisioning. The chosen node's kubelet watches for its assignment, grabs the baton, and begins local setup, acting as the on-site foreman. The crucial takeaway here is that the kubelet is where central control finally meets local execution. And to really show your battle scars, mention that plague,
the pod lifecycle event generator, issues can completely overwhelm the kubelet and flip a perfectly healthy node into a not-ready status.
All right, let's shift gears to Section 4, I.O.N., the execution loop.
So I stands for interfaces. See, the kubelet doesn't actually do the lowest level work itself. It calls on specialized plugins. The CRI pulls the image, the CNI wires up the IP, and the CSI mounts the volumes. When you're talking about this, you absolutely must bring up CNI IPAM exhaustion. It is this notorious silent killer in production where pods just get stuck indefinitely in a container creating state, all because the cluster simply ran out of assignable IP addresses. Next, O is for observation. The kubelet observes the actual physical health of the container and reports the status right back to the API server to compare it against the spec, or the desired intent. This spec versus status handshake, it's literally the heartbeat of Kubernetes. Operationally, if that status fails to update, maybe due to network partitions or a kubelet hanging, the control loop is going to assume the work failed and will relentlessly try to restart the race, which can cause some massive churn. And N is for nonstop reconciliation. That infinite control loop never ever sleeps. It is constantly striving to make the physical reality match the desired intent forever. The key operational metric you want to highlight here is the reconciliation gap. If you see this gap growing, it basically means your control plane is fundamentally struggling to keep up with the physical reality of the cluster, which is a huge red flag for a severe scaling or resource bottleneck. Finally, we arrive at Section 5, Operational Realities and Wrap-Up. So you conclude your answer by stepping back and summarizing the whole C.H.A.M.P.I.O.N framework. Emphasize to them that Kubernetes isn't just about running containers. It's fundamentally about state management. Because this architecture is completely decoupled via the API server, we can swap out a container runtime or even a cloud provider without changing a single line of a developer's YAML. It flawlessly bridges the gap between developer intent and infrastructure reality, which lets us truly treat infrastructure as code. Using this framework guarantees you have complete technical coverage while also demonstrating your ability to pivot effortlessly between deep architectural execution and high-level strategic leadership. So definitely save this framework for your interview prep. Make sure to follow Siva Sankartumala for more deep dive systems architecture. And hey, repost this to help a peer master those cloud-native workflows. As you head into your prep, I'll leave you with this final thought. As Kubernetes continues to evolve, will the node layer itself eventually be fully abstracted away, making this entire execution loop completely invisible to us? Think about it. Until then, you are more than ready for the hot seat.